All right, we're looking at Pythagorean theorem, and let's label some parts. The side that is opposite of 90 degrees, what is that called? Hypotenuse. Hypotenuse. And that is denoted by C. And then we have the two legs, leg A and leg B. So the angles are capitalized, the sides are lowercase. And normally I would say a squared plus b squared, but I'm going to go the other way just for the sake of the next day's lesson. C squared is equal to a squared plus b squared. And were you all exposed to this like back in 7th-ish grade? Okay? All right. Let's try example 1. On example 1, we have, I want to start by labeling. So we know this one is C. A and B is interchangeable. Doesn't matter which one you make it. Let's start with the formula. C squared is equal to a squared plus b squared. This should be naturally memorized. And we have x squared is equal to 4 squared plus 8 squared. Then I have x squared is equal to, what is 4 squared?
16.
Plus how many?
64.
Very good. So when I add 16 and 64, we get how many? Ooh, 80. I'm like jumping ahead. And then to make x by itself, we have to square root. That's what we were rationalizing a while ago, or simplifying the radical. So square root and the square cancels each other out. So then I have x by itself at the moment. Let's simplify the 80. What two numbers can we think of if you want to be clever with a perfect square? Square root 4 and square root 20. Okay, I like that. But then, can 20 be further split with the 4, possibly? Square root 4 and another root what? 5. Very good. And I was initially thinking about 16 times 5, but you can always further split. Nothing wrong with it. So 4 comes out. Radical 5 remains. And that is our C. Okay, for number 2, what is odd about number 2 compared to number 1? We have like an expression, right? Anytime you have more than one component, always put that as parentheses. So let's label. We know the largest side is opposite of the right angle. That's my C. Doesn't matter which one your A and B is. And let's start with the formula. C squared is equal to a squared plus b squared. Oh, that's a wonky B. My C has x plus 4 all squared. And my A is x squared, B is 12 squared. Are y'all okay if I just write out 144 right now?
Yeah.
Okay? So then, let's kind of go back to Algebra 1. When I'm looking at this piece right here, can y'all actually FOIL in one go? Would you agree if I say x squared plus 16? I hope not. That is incorrect. Because when you're squaring something with the whole component, it's happening twice. And when it's happening twice, you're eliminating the middle term by saying x squared plus 16. So let's actually do this one. X times x is x squared. X times 4 is 4x. And then my second one, 4 times x is 4x. 4 times 4 is 16. Y'all see how that middle term was completely eliminated by creating made-up shortcut? Okay, so be really careful. So we know all that is going to be x squared plus 8x plus 16 is equal to x squared plus 144. Are we good on the steps so far? So do not make up your own math. It sounds kind of right, but it's really not. So then what's on the left and the right side of the equation that I could eliminate? X squared is gone. That's nice. And if I were to do my tedious algebra 1, that's going to be 144 minus 16. How many is that? 128? Somebody confirm?
Yes.
128. And when I divide it by 8, we know 8 goes into 12 one time. has a remaining of 4. So 48 goes into, 8 goes into 48 how many times? And that is our final answer. So if you make any mistake, it's going to be algebra error by making up some math on your own. All right, let's do example number 3. Chapman, will you read number 3, please?
According to the safety ratio of 4:1, how high will a 30-foot ladder reach when placed on a wall?
So anytime you see a ratio, that means we have the same variable. So again, point at ratio and write on there same variable. So really in the end, it's 4x to 1x. So let's go ahead and label them. So I have this right triangle. And 4 to 1 will be 4x to 1x. And it says we want to figure out a 30-foot ladder. So we have a 30 right here. So let's start with our formula. C squared, that's a squared, is equal to a squared plus b squared. My C is 30. Are we okay if I just put in 900? Is that a yes? Maybe, okay. And then my A is going to be 4x. But because I have more than one component, I'm going to put that in parentheses. Maybe I'll put this one in parentheses, even though we have understood 1. So I'm going to call that A and B. So we have 4x, quantity squared, plus 1x squared. Let's compute. What is 4x times 4x? 16. And then 1x times, x squared. What about 1x times 1x? Just x squared? You can write the 1 in front if you want. And then when I combine like terms, how many x squares are there? Very good. And then we want to divide it by 17 on both sides. That goes away. So I get x squared is equal to 900 divided by 17. And then what do I do on both sides to get rid of the squared part? Square root. And the square root and the square cancels each other out. And I'm going to do something. Is this square root of 900 already 30?
Yep.
So I'm just going to write in here 30 over radical 17. What is not allowed on the denominator? Radical. So we need to do what operation?
Multiplication.
Oh, rationalize. And I see why it is multiplication. I agree with you, partially. So we know our x is 30 radical 17 over 17. Now looking at the whole numbers, can I further simplify 30 over 17? Nope. Have I answered the question though? How high will the 30-foot ladder reach? So that's going to be the vertical piece. If x is 30, did I write the whole thing? Yeah, 30 radical 7 over 17. All I need to do is multiply by what number right here? 4. So if I take 4 times all of that, is 4 4 over 4 or 4 over 1? 4 over 1. So am I taking the 4 and multiplying by 30 alone or both the 17? Just the 30. So when I do, I will be 120. I know this is quite annoying, right? Can I further split the whole numbers? Nope. All right. The next thing that I'm going to share with you, if you choose to not remember this, it is not going to hurt you. But it will definitely help you on your ACT and SAT. So we have something called the Pythagorean triple. And the most commonly used is the first 3, but I'm still going to share the first 5. So let's write out the following on the margin. Leg, and hypotenuse. I think my thumb's really mad at me right now. What are you doing? Okay, so the following I want you to memorize, but if you choose not to memorize, it is okay. We have something called 3, 4, 5, 5, 12, 13, and 7, 24, 25. These 3 are the most often used. But then if you're ambitious, you may memorize the next one, We have 8, 15, and 17. And 9, 40, and 41. And I'm going to show you how to use these. These are all Pythagorean triples for the following reason. What is 3 squared? 9. What is 4 squared?
16.
What is 16 plus 9? So is 5 squared also 25? Okay? All right, let's see how to use it then. And I'm going to only apply it with number 1 and number 4. The other ones will not matter. So then, since every Pythagorean theorem has to do with the leg, and hypotenuse. And I know the hypotenuse is a question mark, correct? So I'm going to call that the x. And I want to write the smaller leg first and then the larger leg. So 63 is my smaller. And then 216 is my bigger. And then I'm going to go to the side over here and ask myself, which one has a same ratio? So 63, 3 can go in, 5 can go in, 7 can go in, correct? So 3 can go into 63 how many times? How many? 21, right? Does that mean 4 times 21 is also 216? No. So then I'm going to go to 7. And since I know that is the answer, I'm going to write it down. Okay. So then, 7 goes into 63 9 times. Do we agree on that? Yeah? 24 goes into 216 also 9 times. So that means 25 times 9 is my unknown x. Can someone do 25 times 9 in their head? You have 9 quarters. How much? $2 and 25. Okay, see if you can apply that to number 4. 4 is a little bit different, but let's talk about it. Can someone tell me which Pythagorean ratio they used? 5, 12, 13. Okay, so 5, 12, and 13. The only iffy part is, I know this 25 is a leg. We won't know if it's going to go into this one or this one, but we know it's clearly divisible with who? 5, so I'm going to put that underneath. And then 13 is going to get 65. So 5 times what is 25? 5 times 5? Is 13 times 5 65? So then 12 times 5 is how many? Boom.